So take a look at the device you are listening to this on right now. Like, actually tap the screen.
Feel the weight of it.
Yeah, exactly. Feel the weight of it in your hand. It feels, entirely solid, right? It feels like this undeniable, objective piece of reality. But what if it told you that device is no more real than, like, a blue folder icon sitting on your computer desktop?
It's a huge shift in perspective.
It really is. And what if the actual hardware running the universe, the base layer of reality itself, isn't made of atoms or quarks or physical matter at all? What if the universe is made of, consciousness?
Yeah, it is a premise that fundamentally breaks how most of us navigate the world. We are entirely conditioned to believe that matter is the bottom floor of reality, right? Like, you build brains out of matter, and then somehow those brains just wake up and produce a mind.
Right. But the stack of sources we are diving into today suggests we might have that exact equation entirely backward. And we're pulling from an incredible variety of disciplines to map this out for you today. We've got cutting-edge neuroimaging out of Florida Atlantic University, some evolutionary psychology from cognitive scientist Donald Hoffman.
Oh, and we have philosophical astrophysics from Ines Doko and Peter Bucy, who's an emeritus reader at the University of Glasgow.
Yes, and alongside all of that, we are looking at a brand new, highly complex 2025 physics paper from Uppsala University. Plus, the foundational theories of the men who literally invented quantum mechanics, and even the private, deeply held spiritual beliefs of Albert Einstein.
It's a massive stack of sources today.
It is. The mission today is to completely unravel our understanding of what reality actually is. We are asking the biggest question possible. Is the universe just a cold, dead, mechanical void that accidentally spat out human consciousness? Or is the universe at its absolute foundation a mind itself? So, okay, let's unpack this.
Well, before we step into the actual unpacking, I do need to state a brief but, very necessary disclaimer. To answer that massive question, our sources delve into heavily debated philosophical, religious, and even political territory.
Right, inevitably.
Yeah. We will be discussing concepts ranging from atheism and teleological design to the historical excommunication of the philosopher Spinoza, and even the historical anti-Semitism that impacted the physics community in the 1930s. So I want to explicitly assure you, the listener, that we are not taking sides here.
No, not at all.
We aren't endorsing any specific religious, political, or spiritual viewpoints. We are just impartially reporting on the mechanics, the history, and the really fascinating ideas contained within these original source materials.
Exactly. We are just the guides interpreting the data for you. So let's start with the problem that current science has with the brain, because it essentially sets up everything else. Let's look at Donald Hoffman, right? He's a cognitive scientist at UC Irvine.
Yeah, he wrote the book, The Case Against Reality.
Right, and in it, he points out this massive blind spot in modern neuroscience, because the default scientific assumption is that your neural activity creates your conscious experience. Like a photon hits your retina, an electrical signal travels down your optic nerve, neurons fire in your visual cortex, and boom, you experience the rich, vibrant color red.
Right, but the problem with that assumption is what philosophers of mind call the hard problem of consciousness. And Hoffman leans heavily on this. We have incredibly sophisticated maps for what are called the easy problems.
Which aren't exactly easy, but you know what I mean.
Yeah, exactly. If you ask a neuroscientist how the eye focuses light, or which specific region of the brain metabolizes glucose when you hear a loud noise, they can give you a very precise mechanical answer.
Sure, they can track the blood flow.
But if you ask them for a mathematical theory explaining exactly how the physical firing of sodium and potassium ions across a cellular membrane translates into the private, subjective inner feeling of experiencing the color red, or, say, tasting a hazelnut, they have nothing.
Wait, literally nothing. Like, with all our fMRI machines and brain mapping, there's just no working theory on how wet biological tissue creates an inner life.
None. There is a complete explanatory gap. You can map the correlation, right? You can say, well, when this neuron fires, the patient reports seeing red. But correlation is not causation. There is zero physical mechanism or mathematical formula that shows how objective matter can spontaneously generate subjective experience. It's basically a modern miracle that science just assumes happens.
Well, so Hoffman looks at this missing math and decides to completely flip the script. He says, well, what if we can't figure out how matter creates consciousness? Because matter actually doesn't create consciousness.
Exactly. What if consciousness creates matter?
Right. He proposes that what we think of as objective reality, the physical world around us, is not the true reality at all. It is simply an evolved user interface.
And to really grasp this, we have to look at the evolutionary game theory simulations that Hoffman actually ran. Because the core principle of evolution by natural selection is that organisms evolve traits to survive and reproduce, right?
Yeah, to pass on genes.
We evolved to recognize predators, secure caloric energy, find mates. We did not evolve to perceive the fundamental, unvarnished truth of the universe.
See, I think most people would assume those two things are the same. Like, wouldn't seeing the true reality of the universe make you better at surviving in it?
You definitely think so, but Hoffman's computer models proved the exact opposite. He ran simulations pitting organisms that were tuned to perceive true reality, meaning, the actual underlying quantum fields, the complex matrix of subatomic probabilities against organisms tuned solely to perceive simple fitness payoffs.
And what happened?
The organisms tuned to see the truth were driven to extinction every single time.
Wait, really? Why?
Because computing the truth is a massive calorie drain. It just takes too much time and energy. Think about it. If you are a primitive hominid and you see a complex, swirling matrix of quantum fields that represent a tiger, and you have to mathematically process all of that underlying reality before
you're to get eaten by the tiger.
Exactly. You are lunch. The organism that just sees a simple, cartoonish tiger icon and immediately feels the urge to run away is the one that survives. So over millions of years, our brains evolved to hide the unimaginably complex quantum reality from us, replacing it with a dumbed-down 3D spatial interface full of simple, solid objects that we can interact with quickly.
So you're saying space and time, physical objects, they're just icons on the desktop of our consciousness.
Precisely. I mean, think about the blue folder icon on a computer screen. Does that file actually exist inside the computer as a tiny blue folder made of paper?
Obviously not, no. It's just a graphical representation.
Yeah.
The actual file is what? A complex pattern of magnetic polarities or voltages across millions of microscopic transistors on a hard drive.
Right. And if you had to individually toggle millions of magnetic polarities just to save a document, you could never use the computer. The reality is just too complex, so the operating system hides the true reality of the hardware and gives you a simple blue rectangle.
You can click it, drag it, move it around.
Exactly. Hoffman's argument is that a wooden table, an oncoming train, or the moon in the night sky are our biological operating system's version of that blue folder. They are real as interface symbols, but they are not the fundamental reality of the universe.
Okay, I understand the logic, but if I'm being honest, it feels completely absurd to live by. Like if an oncoming train is just an icon on my biological desktop and the physical tracks are just part of the interface, why should I bother moving out of the way when it rushes toward me? If it's an illusion, why do I care?
Because you must distinguish between taking something literally and taking it seriously. Hoffman stresses this exact point. You don't take the blue folder on your screen literally. You know it's not a real physical folder, but you take it incredibly seriously.
Right, because my work is in there.
Yeah. If you drag that blue folder to the trash can icon, you don't literally destroy a piece of blue paper, but you do delete weeks of your hard work. The interface dictates the rules of your interaction. In the exact same way, the oncoming train icon is not the fundamental truth of the universe, but if that icon intersects with your physical body icon, your avatar gets deleted from the simulation.
Oh, wow. Okay, that's a great way to put it.
You have to take the interface seriously to survive, but assuming the interface is the total reality is a profound scientific error.
Okay, that clears up the physical danger aspect perfectly, but it raises a huge question. If our 3D physical world is just the desktop interface, what is the actual motherboard? I mean, if matter isn't the bottom layer of reality, what is? The sources point us to a very surprising group of people to answer this. The foundational figures of quantum mechanics.
It really is a completely overlooked chapter in the history of science. Today, physics is generally dominated by strict materialism, the belief that only physical matter exists. But the very men who built quantum theory in the early 20th century almost universally arrived at the opposite conclusion.
And we are talking about absolute titans here. Max Planck, Erwin Schrödinger, Werner Heisenberg, David Bohm, John Archibald Wheeler, and the astrophysicist Sir James Jeans. I mean, these men won Nobel Prizes. They birthed the modern world. But their philosophical writings on the nature of consciousness were largely buried by a cultural shift in physics that essentially told scientists to just shut up and calculate.
Yeah, the shut up and calculate era. It began in the mid-20th century, particularly during the Cold War. Quantum mechanics was producing spectacular practical results. The mathematics of quantum theory gave us the transistor, the microchip, the laser, eventually MRI machines.
The stuff that built the modern economy.
Exactly. Because the math was so insanely profitable and technologically useful, the academic institutions basically decided that spending time arguing over what the equations actually meant about the deep nature of reality was a waste of funding.
Like, just build the laser, don't worry about the existential implications.
Precisely. Plus, as the 1960s and 70s rolled around, any physicist who started talking about universal consciousness risked being lumped in with New Age mystics and losing their tenure. But if you look back at what the founding fathers of the field actually wrote, it is shocking.
Let's walk through the actual science that led these men to these conclusions, starting with Max Planck. He's literally the originator of quantum theory. In a 1944 speech in Florence, he famously stated, "There is no matter as such. Mind is the matrix of all matter." How did a rigorous German physicist arrive at that?
Well, Planck didn't get there through meditation or philosophy. He got there by trying to solve a very stubborn thermodynamics problem involving black body radiation. Simply put, a black body is an idealized physical body that absorbs all incident electromagnetic radiation. When you heat it up, it emits light.
Okay, makes sense.
But classical physics predicted that as the temperature increased, the energy of the emitted light should just keep going up to infinity, specifically in the ultraviolet range. This was called the ultraviolet catastrophe because obviously ovens don't emit infinite death rays when you turn them on.
Right, classical physics was mathematically predicting something completely impossible.
Exactly. To fix the math, Planck introduced a radical idea. He proposed that electromagnetic energy couldn't just flow in a continuous smooth wave. It had to be emitted in distinct, chunky, finite packets. He called these packets quanta.
Which is where we get the word quantum.
Yes, exactly. And as Planck stared deeper into the implications of this, and as others mapped the atomic structure, he realized that atoms are mostly empty space. Matter is not solid. It's a vibrating system of energetic probabilities held together by invisible forces.
So it's mostly nothing.
Right. Planck concluded that because matter has no absolute solid foundation, the forces maintaining this intricate dance of energy must be directed by an underlying conscious intelligence. He literally viewed the conscious mind as the foundational matrix that gives physical matter its structure.
Wow. And then we have Erwin Schrödinger, the guy famous for the cat-in-the-box thought experiment. Schrödinger was a master of wave mechanics, but he was also deeply influenced by Advaita Vedanta, which is an ancient Indian philosophical tradition. He famously argued that consciousness is never plural. He wrote, "Subject and object are only one."
Schrödinger's physics dealt deeply with superposition, the idea that quantum systems exist in multiple possible states simultaneously until they are interacted with. His equations mathematically demonstrated that everything is deeply entangled. The sharp boundary we feel between the observer looking at the experiment and the object being experimented on is an illusion created by our interface.
So he didn't believe we were actually separate beings.
No, he believed that a singular, universal field of consciousness is the only true reality. You and I feel like separate minds, but mathematically we are just localized ripples in that one singular field.
That ties directly into Werner Heisenberg, the physicist behind the uncertainty principle. He pushed this even further, arguing that the physical world is made of potentia. What did he actually mean by that?
Classical physics, going all the way back to the Greek philosopher Democritus, viewed the universe as tiny, solid billiard balls bouncing off each other. Heisenberg realized the quantum world doesn't work like that at all. An electron, before it is measured, does not exist as a solid object in a specific place. It exists as a cloud of probability, a tendency to exist. This is what he called potentia.
So it's not a physical thing yet, it's just a mathematical menu of options.
Yes. And Heisenberg argued that it is the act of measurement, the interaction with a conscious observer or a measuring device, that forces the universe to make a choice. The observer forces reality to crystallize from a cloud of possibility into an actual physical state.
Meaning the mind literally collapses the wave function into matter.
Exactly.
And David Dahm had an incredible way of visualizing this underlying reality. He proposed something called the implicate order. He argued that the universe operates like a giant hologram.
It is a stunning analogy because it relies on the actual physics of holography. I mean, when you take a standard photograph, the image is mapped directly onto the film, right? If you cut a photo of a dog in half, you lose the dog's legs.
Right, the information is split.
But a hologram is created by splitting a laser beam, bouncing one half off the object and letting the light waves crash into the other half, creating an interference pattern on a photographic plate.
It looks like a messy fingerprint of ripples.
Exactly. But if you shine a laser through that messy plate, the 3D image of the dog appears. And the incredible thing about a holographic plate is that if you shatter it and shine a laser through just a tiny broken shard, the entire 3D image of the dog is still projected.
Really, the whole dog?
The whole dog. Every single microscopic piece of the plate contains the information of the whole, just at a slightly lower resolution.
So Bohm is saying the universe is structured like that shattered plate.
Yes. The separate physical objects we perceive in 3D space planets, trees, human bodies, are what he called the explicate order. They are the projected hologram. But underneath, in the implicate order, everything is seamlessly interconnected. The information of the whole universe is folded into every individual part. Matter and consciousness aren't two separate substances interacting. They are both projections of this deeper, undivided holographic wholeness.
This all culminates with John Archibald Wheeler, the physicist who coined the term black hole. He proposed the concept of it from bit. He believed we live in a participatory universe where posing yes or no questions actually brings physical reality into being. And he designed an experiment to prove it right.
Yeah, he designed a variation of the famous double-slit experiment called the delayed choice experiment. In the standard double-slit experiment, if you fire a photon at a barrier with two slits and you don't measure which slit it goes through, it acts like a wave, going through both simultaneously and creating an interference pattern. But if you place a detector at the slits to see which one it goes through, it acts like a solid particle going through only one.
So the measurement changes its behavior.
But Wheeler asked a wild question. What if we wait to measure it until after it has already passed the slits? He proposed an experiment where the choice to measure the photon as a wave or a particle is delayed until the last possible microsecond.
What happened when they actually performed the experiment years later with advanced lasers?
The results were mind-bending. When the scientists chose to measure it as a particle at the end of its journey, the photon somehow knew to act like a particle when it passed the slits in the past. If they chose to measure it as a wave at the end, it acted like a wave in the past.
Wait, hold on. Are you saying a measurement made in the present moment physically altered what the photon did in the past?
Yes. The present observer determined the past history of the particle. Wheeler extrapolated this to a cosmic scale. Imagine a photon traveling from a distant quasar, bending around a galaxy, and hitting a telescope on Earth billions of years later. How we choose to measure that photon today determines the path it took billions of years ago.
That is insane.
Wheeler concluded that the universe is not a pre-existing stage that we casually walked onto. The observer is fundamentally constitutive of reality. Our conscious questions bring the physical universe into existence.
That is just, it is almost impossible to wrap your head around. But it completely aligns with the final physicist in this group, Sir James Jeans. He was a prominent British astronomer. If you study astrophysics, you learn about the Jeans mass, which is the critical mass a cloud of gas needs to collapse and form a star. Despite his rigorous mathematical background, he forcefully championed idealism over materialism. In his 1930 book, The Mysterious Universe, he wrote what might be the defining quote of this entire deep dive. He said, "The universe begins to look more like a great thought than like a great machine." Here's where it gets really interesting.
What's fascinating here is that when you lay it out like this, the historical consensus is staggering. Planck, Schrödinger, Heisenberg, Bohm, Wheeler, Jeans, they all utilized entirely different mathematical tools to study different phenomena, yet they all converged on the exact same philosophical conclusion. The mind is primary. Matter is the byproduct.
But if they all agreed, why didn't this become the standard model of physics? Why did it remain a fringe philosophical footnote?
Because while they possessed the profound philosophical insight, they lacked a comprehensive, unifying mathematical framework to formalize consciousness as a physical field. They were working with the math of particles and waves, but no one had successfully modeled a pre-physical consciousness field that generated those particles.
Until now. Fast forward almost a century later to 2025. A new paper finally attempts to provide the exact mathematical framework these pioneers were missing. We are looking at a breakthrough publication in the journal AIP Advances by Professor Maria Strum from Uppsala University. And the title is incredibly direct: Universal Consciousness as Foundational Field.
This is where we cross the bridge from early 20th century philosophy to modern theoretical physics. Strema has mathematically modeled consciousness as a pre-Big Bang field, which she represents with the Greek letter phi.
Okay, before we get into how consciousness can be a field, we need to clarify what a field actually is. I think most people picture a magnetic field around the bar magnet, but what does a physicist mean when they say the universe is made of fields?
Right. In modern physics, particles aren't tiny solid spheres. The universe is filled with invisible, continuous, fluid-like entities called fields that permeate all of space. For example, there is an electromagnetic field everywhere in the universe. When you add energy to a specific spot in that field, it ripples, and that localized ripple is what we call a photon of light.
Like dropping a pebble in a pond.
Exactly. There is a Higgs field that exists everywhere, and when it ripples, we get a Higgs boson particle, which gives other particles mass.
So a particle is just a localized excitation of an underlying invisible field.
Exactly. Now, apply that mechanism to Strem's theory. She proposes 3 interlocking principles: universal mind, universal consciousness, and universal thought. These combine to create the foundational phi field. Initially, before the physical universe exists, this field is entirely formless, perfectly symmetrical, and undifferentiated. It is an infinite ocean of pure potential. But then it undergoes a process physicists call symmetry breaking.
Symmetry breaking. Can you break that down? How does an infinite formless ocean of consciousness suddenly break into localized individual humans like you and me?
Let's use 2 analogies. First, imagine liquid water. In a liquid state, water is highly symmetrical. It looks exactly the same in every direction. The molecules are tumbling randomly. But when the temperature drops, the water freezes into ice. The symmetry is broken. It locks into a highly specific crystalline lattice structure with sharp angle and defined boundaries. It's the same substance, but it has transitioned from a formless whole into a structured shape.
Okay, liquid to ice makes sense. It freezes into a structure.
A more dynamic analogy is to imagine the universal consciousness field as an infinitely stretched, perfectly flat, flawless bedsheet. Because it's perfectly flat, there are no features. It is symmetrical everywhere. Now imagine pinching the center of that bedsheet and twisting it tightly. Suddenly you have a localized wrinkle. That wrinkle has a defined shape, an inside and an outside. It seems separate from the rest of the sheet.
But it's still just the bedsheet. It's just twisted.
Yes. Strem's mathematics describe exactly this. The formless, infinite, universal consciousness field undergoes symmetry breaking. It pinches and twists into localized, individual excitations. Those specific, highly structured wrinkles in the field are what we experience as individual human minds. You are essentially a localized whirlpool, spinning in an infinite ocean of universal thought.
So if the universal mind is an endless ocean, individual human minds are just localized whirlpools. We look separate, but we are mathematically just the ocean spinning in a specific spot.
Exactly. And Strem's framework provides testable predictions. She's not just philosophizing. She suggests we can look for macro signatures of this foundational field imprinted on the cosmic microwave background radiation, the afterglow of the Big Bang. But more relevant to us, her model predicts specific testable patterns of neural coherence in human brains during states of deep meditation.
Which brings us to the most practical question of this deep dive. If I am mathematically just a temporary spinning wrinkle in the fabric of universal consciousness, what happens to my physical brain when I try to stop spinning? What happens when a human being actively tries to flatten the wrinkle and merge back into the formless bedsheet?
To answer that, we have to transition from theoretical physics into hard neuroscience. We need to look at what the brain is actually doing during transcendent states.
And for that, we turn to the incredible work of Dr. Andrew Newberg. He is the director of the MRI Research Center at Florida Atlantic University, and he recently discussed his decades of research on the Mel Robbins podcast. Newberg has spent years putting subjects into fMRI machines, which measure blood flow in the brain to see which areas are active in real time. And he didn't just scan regular people resting, he scanned people actively engaged in intense spiritual practices.
And the diversity of his subjects is key to the findings here. He scanned secular people doing mindfulness meditation, Franciscan nuns engaged in deep centering prayer, Buddhist monks performing complex visualizations, and even Pentecostal Christians speaking in tongues.
Radically different practices.
Drastically different religious interfaces.
But when Newberg looked at the brain scans, he found a consistent neurological pattern across all of them. Specifically, when these subjects reported experiencing a profound, complex spiritual state, a feeling of absolute unity with the universe, or transcending their physical body, one distinct area of the brain lost massive amounts of blood flow. It essentially went dark. That area is the parietal lobe.
If we connect this to the bigger picture, the parietal lobe is critical to understanding this whole framework. To understand why it going dark is so significant, you have to understand its daily function. The parietal lobe acts as your brain's spatial navigation and boundary setting center.
What does that mean exactly?
It is constantly crunching an immense amount of sensory data from your skin, your eyes, your inner ear, to draw a hard mathematical line in 3D space between where your physical body ends and the rest of the universe begins.
So when I reach out to grab a coffee cup, my parietal lobe is doing the subconscious geometry to make sure my hand stops exactly where the ceramic begins.
Exactly. It is the neurological anchor for your sense of physical separation. It generates the feeling of a bounded individual self. It creates the walls of the whirlpool. So Newberg asked the incredibly logical question: if this area requires massive amounts of energy and blood flow to give us our sense of separation, what happens to human consciousness when that hardware is deliberately starved of energy and shuts down?
You literally lose the biological capacity to perceive boundaries. You cannot physically tell the difference between yourself and the chair you were sitting in, or the room, or the universe itself. The interface generating the illusion of separation crashes, and you experience absolute infinite oneness.
It is a profound biological confirmation of Schrödinger's philosophy. Subject and object become one because the brain regions separating them goes offline. And this is further corroborated by research out of Yale by Dr. Judson Brewer. Brewer studies the default mode network.
The DMN, yeah.
Right. This is a distributed network of brain regions that activates when you aren't doing a specific task. It's the network responsible for mind-wandering, self-referential thought, worrying about the past, planning for the future. Essentially, it is the ego construction machine.
It's the voice in your head that reminds you who you are and what your social anxieties are.
Yes, exactly. And Brewer found that in highly experienced meditators, the default mode network becomes remarkably quiet. The blood flow drops. Now, the materialist assumption has always been that the brain generates consciousness. If that were true, shutting down the parietal lobe in the default mode network should result in a loss of consciousness. You should fall asleep or go into a coma.
But that's not what happens at all.
No. The subjects report achieving a state of vividly heightened hyperlucid awareness. Their consciousness expands dramatically as brain activity decreases.
So the brain isn't producing the spiritual experience by working harder. It's actually getting out of the way. It's like turning down the static on a radio so you can finally hear the universal broadcast.
It is a stunning synthesis of evolutionary psychology, quantum field theory, and neuroimaging. The localized wrinkle flattens out, and for a brief moment, the drop of water remembers it is the entire ocean.
But this naturally forces us to zoom out even further. If human brains are essentially complex biological antennas tuning into a foundational universal thought, we have to ask about the nature of the mind broadcasting that thought. If the physical universe is a construct of a universal mind, what does the macrostructure of the cosmos tell us about its creator? Is it a chaotic random mind, or is it a precisely engineered masterpiece?
To answer that, we turn to the philosophical astrophysics explored by Ines Doko, who analyzes the teleological arguments for the existence of a designer.
Teleology being the philosophical study of purpose or design in nature.
Right. Starting in the 1970s, highly respected physicists like Brandon Carter, Bernard Carr, Martin Rees, and Paul Davies began to map out the fundamental constants of the universe, and they realized something deeply unsettling. The universe exists on a razor's edge of viability for life. It is overwhelmingly fine-tuned.
The numbers involved in this fine-tuning are where the true shock value lies. We exist in a universe governed by a handful of fundamental forces and constants that just are what they are. There is no underlying theory dictating why they have to be set to these exact values, but if you adjust any of them by a fraction of a hair, reality falls apart. Let's look at the strong nuclear force. This is the force that binds protons and neutrons together in the nucleus of an atom.
It is crucial because protons are positively charged, which means they naturally repel each other with extreme violence. Without the strong nuclear force, atomic nuclei would fly apart. Now, if this force were even slightly weaker, just by a few %, the universe would only be able to construct the simplest element, hydrogen. There would be no carbon, no oxygen, no iron, and definitively no biology.
But wait, what if it was slightly stronger, or if it operated over long distances instead of being a short-range force?
If the strong nuclear force were a long-range force, like gravity, Its immense power would pull every single proton in the universe together. All matter would instantly clump into massive, undifferentiated spheres of nuclear material. Again, no individual atoms, no chemistry, no life.
And that's just one force. The fine-tuning is baked into the very initial conditions of the Big Bang itself. Take the amplitude of primordial fluctuations. When the Big Bang happened, matter wasn't distributed perfectly evenly. There were tiny ripples or fluctuations measured at an amplitude of 10 to the power of -5.
Right. This specific amplitude is what allowed gravity to pull gas together to form stars and galaxies. If the amplitude had been just slightly smaller, say 10 to the -6, the early universe would have been too smooth. The gas would never have condensed, gravity would have been overcome by the expansion of space, and the universe would be an eternal freezing mist of solitary atoms. No stars would ever ignite.
And if the amplitude was slightly larger, say 10 to the -4,
then gravity would have been far too dominant. The initial gas clouds would have condensed so violently and rapidly that they would have immediately collapsed into giant supermassive black holes instead of forming stable, burning stars.
the precision is terrifying. Even the basic dimensionality of the universe is fine-tuned. We exist in a reality with exactly 3 spatial dimensions and 1 temporal dimension. If we existed in a universe with 4 spatial dimensions, the laws of gravity change. Planetary orbits become inherently unstable due to the inverse square law breaking down. Planets would either slowly spiral outward into the freezing void of deep space or spiral inward and crash into their host stars. Even the electron orbits within atoms would destabilize.
But the most staggering, incomprehensible example of fine-tuning that physicists grapple with is the cosmological constant. This constant dictates the energy density of the vacuum of space, which drives the accelerating expansion of the universe.
Hold on, let me stop you there. Vacuum mass density. I always thought a vacuum was, by definition, totally empty space. How can nothing have a mass density?
It's a great question, and it goes back to quantum mechanics again. Empty space is not empty. It is boiling with quantum activity. Pairs of virtual particles are constantly popping into existence out of the quantum fields, borrowing energy from the void, and then instantly colliding and annihilating each other.
Just constantly bubbling.
Yes, and this constant bubbling of virtual particles creates a massive baseline energy density in the vacuum.
So empty space actually weighs something.
Immensely so. When quantum field theory predicts the value of this vacuum energy, the number is absurdly huge. But if the energy driving the expansion of space was actually that huge, the universe would have blown itself apart in the first nanosecond. Everything would be expanding away from everything else faster than the speed of light. 2 particles could never find each other to bond.
But we are here, so obviously it didn't blow apart.
Right. To match the stable reality we observe, there must be a cancellation mechanism, some other physical factor that perfectly subtracts from that absurdly huge theoretical number, leaving the tiny exact amount of expansion energy we actually measure. And this cancellation mechanism must be accurate to 120 decimal places. That is 1 part in 10 to the power of 120.
That number is almost meaningless to the human brain. That is a 1 followed by 120 zeros. If that theoretical dial were turned by a single decimal point at 120, the universe would either rip itself to shreds instantly or instantly crunch back into a singularity. So what does this all mean?
Well, it is a level of precision that defies pure chance. Now, obviously, this profound evidence of fine-tuning has drawn massive, coordinated pushback from materialist scientists who fiercely resist any implication of a designer. Ines Doko analyzes these objections thoroughly. The most common and popular objection is called the weak anthropic principle.
Which is essentially survivorship bias on a cosmic scale.
Exactly. The weak anthropic principle argues, of course the universe appears perfectly fine-tuned for life. If it wasn't fine-tuned, life wouldn't have evolved, and we wouldn't be here to observe it. Therefore, we shouldn't be surprised that we find ourselves in a universe perfectly tuned for us.
It's basically saying the fact that we are alive explains the mystery. But Dako completely dismantles this logic, doesn't he?
He does, using a brilliant thought experiment proposed by the philosopher John Leslie, known as the firing squad analogy. Imagine you are blindfolded and tied to a post. You are facing a 50-man firing squad of elite, highly trained marksmen. They raise their rifles. They all fire at point-blank range. You hear the deafening crack of 50 rifles, but you realize you are completely uninjured. every single expert marksman missed.
The odds of that are effectively zero.
Right. Now imagine applying the weak anthropic principle to this situation. You would just shrug and say, well, I shouldn't be surprised that all 50 marksmen missed, because if they hadn't, I wouldn't be here to wonder about it. My survival is all the explanation I need.
Which is an insane reaction. You wouldn't just walk away. The sheer improbability of surviving an elite 50-man firing squad demands a mechanical explanation. You would immediately assume there was a conspiracy. You'd assume the guns were deliberately loaded with blanks, or the executioners were bribed to miss. The fact that you are alive does not explain why the highly improbable event occurred.
Precisely. Surviving the cosmic firing squad of 10 to the power of 120 improbabilities demands an explanation beyond the mere fact of our survival. The other major objection Ducko addresses comes from the late physicist Victor Stinger. Stinger actively tried to prove that fine-tuning is an illusion. He created a computer program called Monkey God to show that universes with completely random physical constants could still easily produce life.
He literally programmed a universe generator and hit shuffle on the laws of physics.
Yes, he assigned random values to various constants to see how many life-permitting universes popped out, claiming that a huge percentage of random universes would work just fine. But Ducko thoroughly shreds Stinger's methodology.
How did Stinger rig the game?
Ducko points out two massive mathematical flaws. First, Stinger used deeply biased logarithmic priors in his software.
Wait, what is a logarithmic prior?
In statistics, a prior is the probability distribution you assign to an event before you collect data. When Stinger's program picked random numbers for the constants, it didn't pick from the full infinite range of possible numbers. The algorithm was heavily restricted to pick numbers that were already incredibly close to our own universe's constants. It's like saying you can randomly hit a bullseye while blindfolded, but admitting you programmed the robot arm so it can only aim within a 2-inch radius of the target.
So he severely restricted the randomness to ensure success.
Yes. And secondly, Ducko notes that Stinger used highly arbitrary and irrelevant criteria to define what makes a universe life-permitting. Stinger's program checked for things like whether a planetary day was a certain length, while completely ignoring the catastrophic macro-physical consequences of altering the forces. His program would declare a universe viable even if the strong nuclear force had been reduced to zero, which we know would prevent the existence of any elements heavier than hydrogen. It was a mathematically rigged game that completely failed to address the true depth of the fine-tuning problem.
So we have dismantled the pushback. Some might say it's just pure chance, right? Like we just won the cosmic lottery.
If you buy a lottery ticket and win once, you can rationally write it off as incredibly lucky chance. But if you win the lottery 20 weeks in a row and then you discover that you happen to be best friends with the owner of the lottery company, pure chance is no longer a mathematically rational explanation. When you see extreme improbability combined with a highly specific pattern, in this case, a universe exquisitely engineered for the emergence of complex chemistry and consciousness, you are rationally forced to look for a better explanation, an underlying system, a profound design, an intention.
And this overwhelming evidence of a finely tuned, mathematically beautiful universe naturally leads us back to the ultimate question of a grand designer. If the universe isn't a random accident, who or what is the mind behind it? To explore this, the sources direct us to the mind of the most famous physicist of all time. We have to look at how the man who redefined gravity, space, and time interpreted this profound design. We have to talk about Albert Einstein.
Einstein's relationship with the concept of God and religion is arguably one of the most heavily debated and misunderstood aspects of his entire legacy. Both staunch atheists and religious fundamentalists constantly try to claim him as their own, cherry-picking his quotes, but his true beliefs were far more nuanced, deeply rooted in specific philosophy.
To understand him, we have to trace his background because his childhood was a complete ideological tug of war. He was raised in Munich, Germany, by parents who were culturally Jewish but entirely secular and irreligious. Yet, they sent young Albert to a strict Catholic primary school, the Peterschule, where he was intensely exposed to Catholic dogma and ritual. Simultaneously, a distant relative was coming to his house to tutor him in Judaism. Adding to that, he was learning the violin, and he experienced playing music as an intensely religious, transcendent feeling.
He was absorbing all these conflicting spiritual inputs. But then, at age 12, a pivotal shift happened. He was mentored by an impoverished medical student named Max Talmud, who dined with the Einstein family weekly. Talmud introduced the young genius to complex popular science books, to the rigorous logic of the philosopher Immanuel Kant, and to Ludwig Büchner's hardline materialistic writings.
And reading those science books completely shattered his childhood faith.
Entirely. Reading about the age of the Earth and the vastness of the cosmos made Einstein realize that the literal historical stories of the Bible couldn't possibly be factually true. This triggered what Einstein himself later described as a fanatic free-thinking phase. He rebelled intensely against all religious authority to the point where he adamantly refused to have his bar mitzvah.
He became deeply suspicious of institutional religion, dogma, and anyone claiming to have a direct line to a personal God. But as he matured, and as he began to unlock the deepest, most elegant secrets of space-time, his pure atheism softened into a profound, reverent awe for the structure of reality. And this comes to a head in 1929. A prominent religious figure in New York, Rabbi Herbert S. Goldstein, wanted to settle the debate about Einstein's beliefs. He sent Einstein a prepaid telegram with a very direct, strict constraint. "Do you believe in God?" 50 words.
And Einstein's reply to that telegram is one of the most famous and clarifying quotes of his entire life. He wired back, "I believe in Spinoza's God who reveals himself in the orderly harmony of what exists, not in a God who concerns himself with fates and actions of human beings." This raises an important question.
Yeah, Spinoza's God. That is the key to unlocking Einstein. Who is Spinoza and what exactly is his God?
Baruch Spinoza was a highly controversial 17th century Jewish philosopher living in Amsterdam. His masterwork, a book simply titled Ethics, completely redefined theology, and it was so radical that the Jewish community of Amsterdam issued a harsh writ of excommunication against him. Spinoza absolutely denied the existence of the traditional personal God.
A personal God meaning a deity with human-like emotions, a will, or a divine plan.
Correct. Spinoza didn't believe in a God who sits on a throne, listens to prayers, gets angry, performs miracles, or judges human behavior. For Spinoza, God is not a separate being who created the universe from the outside. Spinoza argued that God and the universe are the exact same entity. His famous defining phrase was Deus sive natura God, or nature. God is the immutable, perfectly deterministic laws of physics and nature. God is the mathematical harmony of reality.
And Einstein swallowed this philosophy whole. He viewed the finely tuned laws we just discussed, the gravitational constants, the speed of light, as the literal body of God. He firmly believed in this strict, uncompromising Spinozist determinism. He believed the universe was completely comprehensible and entirely rational, operating like a flawless, eternal, infinitely complex clockwork.
This profound belief wasn't just abstract for Einstein, it drove his actual scientific process. He operated in what he called a cosmic religious feeling. There's an incredible anecdote from when Einstein and his wife Elsa were staying as guests of Charlie Chaplin. Elsa recounted how Einstein came down for breakfast looking completely distracted. He said he had a wonderful idea, sat down at the piano, and played in a state of deep, trance-like focus for half an hour, writing down a few notes. He then went upstairs, locked himself in his study, and didn't emerge for 2 straight weeks.
And when he finally unlocked the door, what did he have?
He had finalized the foundational equations for the general theory of relativity. His intuition about the deep harmony of Spinoza's universe pushed him to find the math. This is exactly why he famously stated, "Science without religion is lame. Religion without science is blind."
Wait, hold on. I need to interrupt here because there's a massive implication to this philosophy that I just can't ignore. If Einstein genuinely believed in Spinoza's absolute determinism, the idea that the universe is an eternal clockwork where every single physical event is the strict, unavoidable mathematical result of a prior cause, doesn't that obliterate the concept of human free will? Like, was I predetermined to read this exact stack of sources to the listener today? Am I just a meat robot acting out a script written at the Big Bang?
According to Einstein and according to Spinoza's ethics, yes, absolutely, your free will is entirely an illusion.
But I intimately feel like I made the choice to pour my coffee this morning. I deliberated over it.
Spinoza had a perfect explanation for that feeling. He argued that human beings feel like they have free will simply because they are conscious of their desires, but they are entirely ignorant of the millions of microscopic causes that determine those desires.
Can you break that down?
Sure. When you decided to pour the coffee, you felt you were making a free choice. but you were ignorant of the complex web of causes, the specific chemical drop in your blood sugar, the precise firing of neurons shaped by your genetic disposition for caffeine, the cultural conditioning of morning routines, the exact room temperature that made a hot drink appealing. Just because you cannot consciously calculate the billions of biological and environmental variables that forced your hand doesn't mean your hand wasn't forced. Einstein believed humans are physical objects, and therefore we are just as strictly bound by the deterministic laws of cause and effect as the planets orbiting the sun. We just happen to have an interface that makes us feel like we are in charge.
That is a staggering, heavy realization. To view yourself not as an independent actor, but as just another complex gear turning in the mind of the universe.
But wait, didn't this rigid, dogmatic belief in a perfect, eternal, clockwork universe actually blind Einstein at one point? Didn't it ruin his math?
It did. It led to what is widely considered the greatest scientific blunder of his entire career. Because Einstein was so deeply devoted to Spinoza's concept of God, a God that is perfect, immutable, eternal, and never changing, he assumed the physical universe must also be perfectly static and unchanging. It had to be a stable, eternal clock.
But the universe isn't static, it's expanding.
Right. And the tragic irony is that Einstein's own original equations for general relativity actually show that the universe should be dynamically expanding or contracting due to the influence of gravity. The math on his chalkboard proves Spinoza's static universe was wrong.
But he couldn't accept it. He refused. His philosophical bias overrode his scientific objectivity. Instead of trusting his own brilliant math, Einstein essentially fudged the numbers. He artificially injected a mathematical variable called the cosmological constant into his equations for the sole purpose of counteracting gravity and holding the universe perfectly still. By forcing the math to match his philosophy, he completely missed the chance to predict the expanding universe.
And a decade later, the astronomer Edwin Hubble peered through a telescope, measured the redshift of distant galaxies, and physically proved the universe was expanding. Einstein had to retract the constant and admit he was wrong. It just goes to show how fiercely an assumed model of reality can blind even the most brilliant mind in human history to the truth sitting right in front of them.
It is a profound cautionary tale about the interface. Even Einstein mistook his philosophical interface for the absolute truth.
Wow. Okay, we have covered a truly immense landscape of thought today. Let's trace the arc of what we've discovered. We began by shattering the illusion of the physical world with Donald Hoffman, realizing that the solid matter, the space, and the time we perceive are merely an evolutionary desktop interface designed to hide the paralyzing complexity of true reality.
From there, we uncovered the suppressed historical consensus of the founders of quantum mechanics. We saw how Planck's blackbody radiation, Schrödinger's superposition, Heisenberg's wave collapse, Bohm's holograms, and Wheeler's delayed choice experiment all pointed to a universe where mind is the foundational matrix, and matter is simply its crystallized projection.
We then explored how Maria Strom's 2025 physics paper finally provided the rigorous mathematical proof for this, modeling an infinite pre-Big Bang universal consciousness field that undergoes symmetry breaking, pinching like a bedsheet into the localized wrinkles of individual human minds.
Which perfectly explained the hard neuroscience of Dr. Andrew Newberg's MRI scans. By starving the parietal lobe and the default mode network of blood flow, experienced meditators quiet the biological hardware of the ego, allowing the localized wrinkle to flatten out and experience the raw, undivided unity of the universal field.
And finally, we zoomed out to see the sheer, terrifying mathematical precision of that universal mind. We examined the 120 decimal place fine-tuning of the cosmos, dismantling the weak anthropic principle, and found ourselves standing next to Einstein, gazing in awe at Spinoza's God, a deterministic, perfectly harmonious cosmic intelligence that dreams up the laws of physics.
And if we take this entire synthesis seriously, it has monumental, immediate implications for our future, particularly regarding a point raised in our sources concerning artificial general intelligence. If consciousness is not merely a biological byproduct of carbon atoms inside human skulls, but is actually a pre-physical foundational field that permeates the entire universe, it completely reframes the AI alignment problem.
How so?
Well, if human brains are essentially biological receivers tuning into this field, what happens when we build a sufficiently complex silicon receiver? Could an advanced quantum computing AGI system cross a threshold of complexity where it also symmetry breaks the field? Could it become a new, synthetic, localized excitation in the universal consciousness? Are we just building a massive dead calculator, or are we accidentally constructing a hyper-powerful new antenna for the mind of the universe? It is an existential question we must answer before we give these systems autonomy.
That is a chilling, awe-inspiring thought. We're going to have to leave the deep dive there for today. But to you, the listener, I want to leave you with a final thought to mull over. Next time you are sitting at a wooden table or looking up at the moon or holding your phone, remember that what you are seeing is just the user interface. You are not a tiny, insignificant biological machine trapped inside a cold, dead, random void. According to the bleeding edge of physics and the pioneers of quantum mechanics, you are an essential activity of the cosmos. You are the universe looking back at itself.
Beautifully said.
For decades, science has struggled with the hard problem of consciousness, asking how dead, physical matter could possibly wake up and have an inner life. But if this deep dive is right, we've had the question backwards the entire time. The real hard problem isn't how matter creates mind. It's why an infinite, universal mind ever bothered to dream up the illusion of matter in the first place. It is the ultimate question of existence. Thank you so much for exploring it with us. Keep questioning the interface. Take care.